Okay, today we're going to be talking about Chapter 9, Section 2 on the real number system. When we're working with the real numbers, we are going to be asked to do a few different things. The first of which is to either compare or order numbers that include radicals. For example, we might be asked to compare the square root of 34 to 5 3/8. To do this, we want to put numbers in the same form. And the easiest form to use here is decimals. So we're going to put our numbers into decimals. So to put square root of 34 into a decimal, we can just type that into our calculator. And what we end up getting is 5.83095, and it keeps going. You don't need to write every number down, just enough so that we can compare. 5 3/8, on the other hand, we again could type it into the calculator, 3 divided by 8 to get our decimal portion, and we get 5.375. Now to compare them, we just look place value by place value. The first place value is a 5 in each one. Then we go over and we have an 8 and a 3. Obviously our 8 is bigger, so that means the square root of 34 is greater than 5 3/8. Okay, we might also be asked to order numbers. So we're going to order 4 1/2, the square root of 17, 4.4 repeating, and the square root of 16. Again, we're going to put them all in decimal form. So 4 1/2 is obviously just 4.5. The square root of 17, we plug it into our calculator and we get 4.1231 ... 4.4 repeating is obviously just 4.444, and it would keep going. And the square root of 16 is just 4. So when we look at those, our smallest number is going to be 4, so that's first. But I'm going to write them with what we started with. So square root of 16. Okay, so then that's gone. And our next smallest number is going to be square root of 17. Then 4.4 repeating, and finally 4 1/2. So the key to these is really just putting them in decimal form and then ordering them like normal. The other action that we may be asked to do is solving equations that contain radicals. For example, x squared equals 64. You're probably already thinking, I know it's 8, but we have to be careful because it could also be negative 8. And this is what I'm going to show you. This is how you're going to do this. You're going to get rid of the squared here next to x squared, and by doing that, you do the opposite. So we take the square root. If whatever we do to one side, we need to do to the other. So the square root of x squared, since this is really just x times x, the square root of x times x is just going to be x. The square root of 64 could be 8, it could be negative 8. So we're going to write this as that x could equal the square root of 64, or x could equal the negative square root of 64. So our answer is x could equal 8, or x could equal negative 8. We may also have to do that with a few more steps. For example, if we had the problem 2n squared equals 170. Okay? We're going to start by getting the n squared by itself. So we're going to divide each side by 2, and we get n squared equals 85. Just like last time, we're now going to take the square root of each side. Square root of n squared, square root of 85. This is obviously n on this side, and we could either have the square root of positive 85 or the negative square root of 85. Since this is not a perfect square, we're going to have to use our calculator, and we can just go out to the tenths place. So that means n is approximately equal to 9.2, or, oops, this should have been an or up here. Or n is approximately equal to negative 9.2. And our last example would be if we have something like x squared over 4 equals 25. Again, we want to get the x squared by itself, so we're going to multiply each side by 4. These cancel. I get x squared equals 100. Take the square root of each side. I get x equals either the square root of 100 or x equals the negative square root of 100, which means x equals 10 or x equals negative 10. Okay, that should do it for section 9.2. Please bring these notes to class tomorrow because you will be doing some practice problems where you will need them.